All right. Hey, everyone. Welcome back to the Urban EV podcast. We are Rob and Scott, and so glad you're here. If you're passionate about EVs, charging infrastructure, and user experience, then make sure you hit that subscribe button right now. Don't forget, you can also catch us on your favorite streaming platforms like Spotify, Apple Podcasts, or YouTube for a more visual experience. Today, we are diving into a topic that feels like science fiction, but is quickly becoming a practical necessity: autonomous EV charging. Imagine a world where EVs can charge themselves, whether in a fleet depot, a crowded public parking lot, or even at the airport, without a driver ever touching a cable. That's the vision driving our guests today. Joining me are Madhav Ayyagari and David Alspaugh, co-founders of Inductive Robotics. Will explore the problems they're tackling, their journeys as founders, where they are in their development, and what the next decade of autonomous systems might mean for EVs and the grid. Madhav, David, welcome to the show.
Thank you, Rob. Thanks, Scott. Glad
Yeah,
to be
Rob,
here.
excited to be here.
Gentlemen, you've got quite an ambitious startup on your hands. So before we dive in, why don't you both tell us about your origin story and how you got here?
Cool. I can go. I used to own a Tesla Model Y in Berkeley when I went to school there, and I used to live in a multifamily without access to EV charging. Used to spend a ton of time traveling to the Tesla supercharger and thought to myself, why can't charging come to me? And why isn't my car charging everywhere I go? That was my thought. And funny enough, we had an entrepreneurship class where I pitched the idea and we got to work on it. And I stuck with it. My fellow students went on to full-time jobs and I stuck with the idea. And we started with this bizarre idea of Roomba style robots coming under your car and charging your car. But the premise was I'm sitting at my university class for many hours. I'm sleeping at my apartment all night. Why isn't my car charging? Why do I have to make a separate trip? And that was how I got started with Inductive Robotics. Met Dave in November 23, and then I'll let him give his story.
Yeah, and when Madhav came to me, we found each other on Work on Climate, the Slack channel there, and you sort of pitched the idea to me, and I was like, this is really interesting. These Roombas are kind of a scary thing to have running around the parking lot. Could be breaking ankles and making pancakes out of these robots. Thanks to big trucks and stuff, but. We worked on it and iterated on it for a while, and I have a background in robotics and hardware, and so we couldn't really kick it from my mind. I was really thinking that there's something here. This is a real problem that needs to be solved, and mix in a little bit of reality into the model, and we found that there really was something to work on here.
So, gentlemen, it's interesting when we first got introduced and I heard this concept, I was like, all right, it's a nice idea. It's somewhat novel. I think, robots doing everything for us. We've all been thinking about that probably since the 1950s. Like, okay, fine. So I don't have to plug something in and you're doing it for me. It's saving me that moment. But it's a lot bigger than that. And that's what I realized after discussing with you. What's becoming increasingly obvious is that EV adoption is outpacing infrastructure growth. And this is a big part of what your solution's about. So why don't you share with us what's going on and why this is such a necessity where the infrastructure isn't quite there yet and may never be there, and why the robots can really help us, facilitate EV growth and adoption.
Yeah, sure. We mainly our solution solves a big problem for commercial parking. And when we talk to these commercial parking operators, this is what we've learned. They think of EV charging as a $5,000 unit which goes on the wall. That's how they think of it. But what they realize very soon is the garage was built back in the 60s. It lacks enough power to support a lot of EVs charging at the same time. What this $5,000 turns into is a big, massive construction project, often goes up to like 60 to 100K. You have to dig, you have to trench, you have to lay the copper conduit, and you have to make EV only spaces. So this is what they told us. We think it is a 5K project, but we end up with a 60K kind of construction project. And now we've taken our revenue generating parking spaces and made them EV only, and we can't make like any money off them. So that's the big challenges. They don't want to give up their revenue generating spots, and they don't want to spend 60 to 100K or more, depending on the location, on updating the infrastructure so that they can get the basic EV charging for their customers. What complicates this is the fact that the commercial parking garages, they lease out the companies like the Lazarus and Metropolis of the world. They lease out these garages from real estate owners, and real estate owners are all about ROI. They want to see a very good 4 to 5 year ROI, which is not possible with the setup. So what you see is a stalemate in this confusion, and EV charging doesn't get set up in this facility. So that's what we are offering them. We are offering them a very low cost way to get up EV charging up and running in their locations, a scalable solution where you don't have to take up a huge infrastructure project every time you have to add a few more EV charging stations. And the most important thing is flexibility. Instead of saying you have to go park in this location on this floor, you can open up your entire floor and say that this entire zone is like an electric zone. You can park anywhere. Our robots will come find your car and charge your car. But that's like the premise. Dave, anything to add, you'd say?
I'll just say that, after this, construction project that people go through in these environments as EV owners, and I'm sure as you guys and the listeners know, what ends up happening is, you show up, the chargers are taken, the chargers are blocked by gas cars,
Yes.
the cords are cut, so at the end, what's interesting is after you go through all this hassle of this big project, you end up with an experience for the EV owner, which isn't that great, right? And we've heard story after story from Apple and Amazon and other big companies that they have whole Slack channels dedicated to shaming people to get off chargers, right? So it's like,
Mhm.
so you have this anxious moment where you're trying to find a charger. Then when your car's done charging, you have this anxious moment as people berate you to get off the charger, right? And so that as we've all experienced, you're not getting off an important phone call to go move your car off the charger, right? And so what that ends up meaning is that charging asset that someone just paid $10,000 plus for, per charger now sits there stranded where it's not getting utilized, right? And so you get really poor utilization for that charging asset that kills the ROI and that kills the momentum for future charging projects, right? And so this is how we've ended up in this tricky moment where people are hesitant to add EV charging, yet it's the number one thing that's blocking EV adoption.
Yeah, and that scenario you're painting is very real, and I think every EV owner can attest to that. And that's when it kind of clicked in my head as well. I'm like, oh, this does happen all the time, particularly in public charging spaces where blocked someone. It's maybe even worse when an EV is parked in an EV charging space, but not actually charging. It's like, no, that's not cool either. I mean, the ICE vehicle infuriates me more, but maybe the EV vehicle parked in that spot and not charging gets me just as angry. I can't decide. So yeah, that's all real. So you've identified the real problem. The ROI solution here is, it sounds legit as well, assuming, of course, that your robot and your system can actually play ball and come in cheaper. So before we even get to how much it costs, talk to us about how it works.
Yeah. So what we do is, instead of a regular charging station, we install a robot docking station. And this is where the robots themselves go to charge. And then we have a smart adapter. And this is a device that the person it plugs into their vehicle. And so when they get out of their car, they plug this device in, they lock their car, and they walk away. They're totally done. That adapter sends a beacon to our system and says, hey, I've got Rob's EV here. It looks like he's at 50% state of charge. And let's get him to 80% by the end of the day. Charging patterns and travel patterns, when you plug in and take out that adapter day over day, and we say, okay, Rob's likely to leave around 4 p.m. today. So we have until 4 p.m. to get him charged. And then we make a list of all those jobs that we have to do, and we prioritize them based on a number of factors, and that's customizable per environment as well. We just send the robots out and we burn down that list. And so we do Rob's car, and we do Scott's car, and we do Madhav's car, and we do Dave's car, just based on that priority. And the robot autonomously moves from the docking station through the parking lot. It's doing obstacle avoidance. It's doing its own navigation and wayfinding. Pulls up either behind or in front of the vehicle based on where the charge port is located on the vehicle. It has an arm. It reaches out and plugs into the adapter. And just note, we're not touching the vehicle at all. And we only touch the adapter. And then once that handshake is made with the vehicle through the adapter, we start deploying energy into that vehicle. So in 30 minutes, we're going to get you 50 to 60 miles of range, depending on how your EV calculates it. And then if we determine you need more energy, no problem. We just send the next robot. And so we're always operating, we'll call symmetrically, in such that one robot is discharging into a vehicle while another robot is charging itself. And that's in our minimum system. And we can, multiple robots, we can go up from there. And so then the robots wayfind themselves back to their docking station and get themselves recharged for the next mission.
And let's get techie for a second. Talk to us about amperage. Talk to us about, I assume this is AC level 2. Talk to us specifically about the rate of charge the best rate of charge that you can offer.
Yeah, so we're designing a product that's actually going to do level 3 charging. So the robot itself is carrying a battery in DC, and so it makes a lot of sense for us to stay in DC. And so we're designing a system now that can do 30 kilowatts DC level 3, which is a better product than that level 2 service.
Yep, it's better.
That a lot of folks are getting in those environments, especially better than managed chargers. And so we're able to do that by leveraging the batteries both on the robot and in the robot docking station, which are pulling on those weak connections all the time. So the number one thing we hear besides cost is I don't have enough power, right? And a lot of times those things are related. And so, I love telling people, you go into these garages, you often see, is it 2 or 4 level 2 chargers? Why is it always 2 or 4? And a lot of times that's because that was the easy power. That was the easy stuff to do. And so people did it because it was easy and cheap. And now as they look to expand, they're like, oh, well, this is now a much bigger project. I've got to fix supply and all that stuff. So what we do is we rip and replace those 2 level 2 chargers. That's, usually it gives you 12 to 15 kilowatts of power, sometimes more. But with that same power, no change to the back end, now we can charge 12 to 15 or more cars in that same environment. And for 2 level 2 chargers, they were probably only getting 3 or 4 vehicles through those chargers on a 24-hour clock. So we use that weak power connection to trickle charge our batteries and then fast deploy energy into the vehicles when they're present.
So, David, I don't know, obviously this is a video interview right now, though most people will be listening to us. But if you could actually have seen me at this moment, there was a light bulb that just popped up over my head when you said that. So you're telling me if I already installed 2 chargers or 4 chargers in my parking garage, that I can basically convert that, and instead of just getting the returns on 2 people charging at once, I could have 10 plus people charging and basically increase my income double, triple, quadruple from what I'm already making.
That's 100% correct.
Yeah, I think the big word is utilization here. I think this has always been like the big issue in EV charging is how can we increase utilization factor? I think we've seen it hover around 10% for many years, and now maybe it's coming up to 15. But with our solution, we can increase it like threefold with the existing power connection.
That's really, really impressive. One last little question here about the tech specs. So you mentioned an adapter. What does that mean? What is that adapter? It's not a normal adapter. You are inductive charging solution. So talk to us more about what that little gadget, that widget does or is, or how one's supposed to get a hold of one to work with the system.
Yeah, and I'll clarify up front, even though we are inductive robotics, we are actually doing conductive charging, but we think about moving, power inductively through the parking garage is how we think about it. But so that smart adapter is, very much like your NACS to J1772 adapter that most of us live with in our vehicles. That lives in your car. It's a small device. Now, when we, install onto that location, and we are specifically targeting locations that have a high rate of return. So this often means like workplaces, golf clubs or courses, similar types of environments where we know we have a history of a high rate of return. So for those who work there in that location, we would make that adapter available upon installation. So we have like a sign up process that says, hey, Inductive Robotics is coming to your site. Sign up for our service. We'll give you that smart adapter that lives in your vehicle. That's yours. And every time you plug it in, we know that's you. And so that's how you would get it for high rate of return folks. Now for transient, what we're doing is we're making a smart locker available. So basically this is like an Amazon locker style system. It lives in a corner, a space in the garage. You blip your credit card. It's a quick workflow and a door pops open and you get that smart adapter. You plug it in and you're ready to go. And so that's how we get those smart adapters available.
How do you get the smart adapters back?
Yeah, great question. We do place a hold on the card to make sure we get that back. And we make some mail-in workflows available for anyone who accidentally walks away with it.
Yeah, our goal here is to be in a scenario where the customers end up having the adapter in their car. So that wherever they go, and if you are enabled in that location, they just plug in and have that seamless experience. So the way we are going to manufacture this is make them very cheap, like your regular Tesla CCS combo adapter, which I remember purchasing, right? That way you just have it in your car every time. And the goal is to, in the first instance, it may be to get it to them, but once it's with them, they'll have it, and then it should be a pretty easy process to use it and then return it if they don't want it.
Yeah, I almost feel like it seems like you guys have thought of everything. When they use it the first time, they're basically borrowing it. If you
Yeah.
want to keep it, keep it, and we'll just charge you for it.
Exactly.
Yeah,
Yeah.
that's it. So
There's
simple. Now I've got my car ready. Yeah, don't have to worry about ordering one or what have you. It's a very simple, seamless solution.
Yeah. There's a bring your own card kind of narrative happening here, both in Europe and in New York too. So that's what we are following. Yeah.
So you guys said, I'm very glad to hear you're not using inductive charging, because that just blows the whole, it would be so inefficient. It would be a complete nightmare. Talk a little bit more about how that connection is made. Like, I've watched all the videos on your website, and even looking at the website, I was like, oh, this is inductive charging. It's going to be terrible. Like, change my mind. How does this actually work? Like, get really techie with me, because I'm super into this idea.
Yeah. So what's really interesting, and I'm just trying to think about how to go at this and not spend the whole hour talking about, robotics connections and conductive charging versus inductive charging. But, I think we explored the inductive path, vigorously to begin with. And, we found the same thing, that it's possible. You could absolutely do it. It wouldn't make a lot of sense by the time you were done, right? It would be, tens of pounds of power electronics and huge efficiency losses. And it was just completely impractical by the end of it. But I think what we have, conductively is, at the end of the day, it's far better, really. What we're doing is creating a connector that is friendly for the robot to connect to the vehicle, right? And so this is something EVs were not designed for. And as a result, we see sort of a plethora of standards that have happened between all the OEMs. So Tesla does it one way with the charge port and the door actuation and the door locking and third-party access to triggering the door and all this stuff. And it's completely different than how BMW does it, which is completely different than how Jaguar does it, which is completely different than how Toyota does it. And so what we found very early on with our concept was that we were going to have to standardize the way that we interacted with vehicles. And that is going to have to be through this adapter. And, we do see a future 10 plus years where this could be standardized. And I really hope the industry does. There was a lot of conversation about NACS a couple of years ago. A lot of commitments were made. The reality is, a lot of vehicles are sold today with the J1772 and a CCS, port. Like, that's the reality.
Yeah.
And we're going to have these vehicles for 15, 18 years. That's what studies are showing, that the actual life of EVs are going to be. It's just like gas cars. We're going to have them in our fleets for 15 to 20 years. So we're going to have this wide range of vehicles for a while. And so that's how we found that this adapter is going to be necessary. We'd love for it to go away in the future, but we want to work with OEMs in creating
the adapter didn't phase me at all. Like because in EVs there's adapters. Like we have adapters.
Yeah, we're used to using them already.
Yeah, it's a common thing. Like, I worked at Revel. We had adapters for the Tesla chargers, because we were using Tritium 120 RTM 175s.
Yeah.
They didn't have Tesla charging ports on them, so you needed an adapter. But I'm just imagining, like, how does this thing ultimately mate with your car in a way that gets you enough connection to deliver the amount of energy you guys are aiming for?
Yeah,
I think maybe we haven't shared the demo video where it actually works that way. Maybe that would have helped. Dave, go ahead.
We'll share some more information with you guys. But what's happening here is, so the adapter is sending the signal to the robot that says, "Hey, I'm in this area," and you can think of that as like a neighborhood. Like we operate in a zip code. The robots don't leave a zip code, but then it's like, okay, here's the street and house number that I'm actually at. That's the parking spot allocation. The robot drives over and it says, okay, now I'm looking for this EV. Let me find it in this location. Oh, I found the EV and I found the adapter. This is all via machine vision, and it pulls up and aligns itself to the vehicle. And that's actually a very good point. I want to just harp on for a second, because we all know parking spaces and garages can be quite narrow. The robot is carefully pulling itself up a few inches off the end of the vehicle, and it's also measuring the space that it leaves in the aisleway next to it to make sure that we're not blocking people. So this is a check that, after having a lot of customer conversations, that our consumers wanted to make sure you're not blocking the aisleway. That's something we focus on. So once a robot is in that position, it's looking at the adapter in the vehicle and it's placing it in 3D space, right? XYZ roll pitch yaw. It's trying to figure out where exactly is that adapter. And we base that off of a model that we have of that vehicle. So we know, like, a Tesla Model 3 like charge port, it's always in the same location relative to the car's location, right? It's not like Tesla made the charge ports different.
Although they don't always, sometimes you're nose in, sometimes you're rear ending,
sure.
right? And that presents a challenge for you.
For sure. It absolutely does. And we have to communicate to the EV owner, you got to park nose in for us to access your vehicle. But once that's in that location, the adapter is always relatively in the same space. And we reach out and we identify that adapter very precisely, and then we connect with it. And you know, that sounds easier than it is. Small imprecisions add
No,
up.
that sounds super hard.
Fair.
No, I'm like imagining like the command module connecting to the lunar lander. Like this.
That's
this
right.
Is not, this is really hard.
That's right.
That's why
Actually,
I'm curious.
I just sent a demo video over email to Rob, but
Okay,
you
cool.
should see it.
Well,
I mean,
we'll be sure to link it in the show notes, by
it
the way.
sounds like science fiction, but it actually works, and it amazes people at how well it works. You should see it in action.
Yeah, because you're describing it super simply, but like this doesn't presuppose that everyone parks the car exactly the way they should park
No,
it. Like there's a lot of work going into getting a plug into a hole. Like that's not easy. Like if you have a human brain and hands, like, yeah, but this is a lot of work.
And honestly, when you start walking around parking garages, you start to realize like, oh, some parking spaces are on a slant, you know, like literally on the ramp. They park on the ramp. Some parking spaces are at a different, you know, pitch than the aisleway itself. So you try it. There are a ton of factors, and to be honest, we wanted to get away from having a robotic arm on the robot quite early because this adds complexity and it adds costs, right? But you start to look at all of the scenarios of parking environments, and you just need that flexibility. You need the robot to be able to adjust to it.
Well, and again, like there's all these inductive solutions. Like I worked a lot in the moped space, and there was a lot of talk about, you know, hey, let's install these mopeds get parked generally in the same place. Let's put a giant induction pad down. But, you know, you waste so much energy in inductive charging. It's completely pointless.
Yeah. There's also like a lesson for us to not name the company after the technology, but
well, I'm thinking maybe Conductive Robotics is what you need to rename your company. It's the only flaw I see this entire plan. Is
No,
the
I mean,
name
because
itself.
Rob sent over the meeting invite, and I saw it. I was like, oh, this could be cool. And then I was like, oh, inductive charging, no. You know, and then I was like, oh, okay, we're good. No.
Yeah.
I mean, genuinely, I think what you guys are doing is super cool. It's super interesting. You know, it's hard. It's a hard problem to solve because nobody parks the same. As you say, David, all the cars are different. You know, I live in Europe and the parking garages it's a madhouse over here. Like, you know, and more problems than you guys describe in terms of infrastructure and all of that. So I genuinely think what you've got is a brilliant idea. You know, I think one of the things that, I guess the complexity of connectors and cables and connecting in general is the amount of energy that you're transferring. And so I imagine there's some innovative design in building a probe that has the appropriate amount of, you know, gauge of wire, gauge of connector, all of that kind of stuff. Because again, that's where you end up with the wide variety NACS, CCS, all that. It's everybody trying to be able to put as much energy into their vehicles as possible.
Yeah, the adapter is where we have the core IP, and that's where we filed a patent around on the interface between a robot and a
more
car.
about the adapter than anything else.
Like, the interesting thing about the adapter is that we wanted a way to get a standardized interface between a robot and a car, and the car can change quite a bit, right? And also the second thing is access to the charging port was a big challenge when we initially thought like, okay, so Tesla has a way to remotely unlock it. Not every vehicle does. And again, the door is always trying to shut down on you.
Yeah, I was thinking that you're going to be fighting that because it doesn't know that there's a dongle in there that's not charging. It just wants to close because there's no juice flowing.
But the way we get over it is once you plug in the adapter starts a 0 amp session with the car. So it's constantly telling, be ready, and it's constantly communicating, and the car is just waiting. And once the robot kind of mates to the adapter, it then sends energy. So that's how we get away from the problem.
The adapter needs a small battery itself so it can kind of keep the communication alive.
Exactly. Yeah. So that's how it works.
Does that small battery charge as the juice flows through so you never have to replace it, or is that something that needs to be changed every 6 months to a year?
So in the initial kind of prototype we made, I think we'll have them charged by ourselves, or like a USB port maybe, but the goal is to have them use some of the charge from the charging session to charge themselves. So that's
you put like another little DC converter in there or something.
Yeah, exactly.
Yeah.
Yeah, because, you know, if you think about it, robotics generally, what we're pitching in a lot of the robotics concepts is not it's being done in different industries today, especially in warehousing and stuff like that. But access to the vehicle is a very tricky challenge to actually overcome. Access to the charge port, you don't want to inconvenience people, and getting access is a big, where is the vehicle? So there's some different things that you really have to solve in order to do what we're doing. And that's what we wanted to protect, was that sort of entry point into the market.
Well, and I see this scaling massively. Like, I was a EV fleet operator in London. I had about 40 transit vans. We had, AC charging for them. That was a total pain in the ass. Charging was our biggest nightmare. And I could see this, but then like also, I've driven a lot of the electric lorries that are available in the UK, and I could see this expanding. I mean, you could conceivably make a really big robot that could interface with something like a semi truck. Like, I can see this scaling in so many different ways. And again, to your point, forget about whether or not you have the electric infrastructure available. It's just like, we had 3-phase, plenty of power available in our warehouse, but like, it had to be in one place. Like, you had to park the van there. And to your earlier point, once it was done charging, a human being had to move it so that you could put another one. Like, conceptually, this is a brilliant idea. I'm really excited for you guys.
And I'm guessing, Scott, you guys had to pay somebody to manage those chargers, right? Move vehicles on and off them, and that's not cheap, right?
Yeah.
No, and they're there overnight because we were charging overnight.
Yep.
No, the whole thing was, and again, charging infrastructure is a nightmare. If you look at implementations of DC charging infrastructure in the States, where you're basically building these, giant charging gas stations that take up so much space, the space can be used for nothing else otherwise. Like, imagine if this was just a regular parking lot full of robots that came around and filled up your car for you, rather than building these purpose-built charging stations. No, I think this is a great idea.
And we see fleets as a very good application for us, and right after commercial parking. And the reason for that is, we've talked to a ton of government fleets, municipality fleets, and what they've told us is, using many available grants back in 2022, where like the 2022, they got electric cars, but they didn't think about charging. So the cars are just sitting there in the parking lot, not being used.
They can't charge them.
Yeah,
One small missing part of the equation.
There are
but I mean, like, even just in terms of talking about capacity, right? Like, we had a guest on last week, who his software essentially helps fleet owners determine how much charging they need. But imagine if you could just scale your charging by adding a couple more robots, rather than having to install permanently fixed charging stations. Like, again, the scalability of this is super cool.
And really, we want to take the burden off the buying decision, right? Like, what's happening today is you're basically making this one decision at a point in time, and you're going to say, is it 6 chargers that are going to get overutilized and deliver a poor experience in a few years? Or am I going to build a dozen chargers that are going to be very poorly utilized for the next few years, hoping that the EVs come, right? And that's a really hard decision to make. It has very real capital consequences. And so what we're providing is de-risking that buying decision, right? It's like, okay, let's start with 2 robots. You need more power? Great. Let's bring a third on, maybe a fourth, right? And so we're able to give you that flexibility. And if we bring 4, and you know what, that's too much. We don't have that many EVs. Great. We'll take the robot back. You're back to 3. You're utilizing the right amount of power. We redeploy that robot somewhere else.
So that's a really brilliant model. It's kind of all this conversation is reminding me of one of my favorite movies, WALL-E. I don't know if anyone's seen it over here. And in that future, all the robots, they push buttons. And I'm like, well, that's silly. Nothing's going to really operate in that manner. Once we reach the future, everything is going to be sort of electronic software based type of solutions. I'm like, no, we need robots to press the buttons. And that's what you guys are doing here. So it's makes perfect sense. So obviously you're handling both the software and hardware solutions. I know you said you already have a patent for the IP for the adapter. Talk to us more about the robot itself. Where are you with the development of that?
Yeah, so we have a demonstration unit we bring to. We were just at the Green Transportation Summit and Expo at Tacoma, Washington, a couple of weeks ago, and we're doing live demos with our demonstration robot, actually charging vehicles. Finding the vehicle in space, connecting with it, all that stuff. That's a lot of fun to bring around. It raises a lot of eyebrows. I love having those conversations. And we're actively designing our next product that we're going to release here Q1 2026. And that is, sort of the full stack of proper battery size, proper arm reach, proper charging rates, and going from what could be to what is, and then delivering that with our pilot customers. And we're excited to, I have a few customers signed up for pilots and not quite yet ready to announce that, but excited to sort of get the robot out in the field and bring people into this is no longer a concept or a visualization. This is reality, right? And we can be on your site ready to go in a matter of days once we start building these.
Yeah, we've charged Teslas, we've charged hybrids, both different. So we've charged a variety of different cars depending on what's in the market. And what we've shown is that the entire autonomous equation works. The robot actually, if you just give it a target, it goes there, it finds the car, it charges the car, and then it goes on to the next car. And we can and the next commercial deployment when we do the pilots would be repeating this over and over again.
I mean, it's super interesting. It just got me thinking about like even battery chemistries doesn't really matter to you. Like once the robot's the robot, you can chuck solid state batteries in the robot. It can charge solid state batteries. It's probably backwards and forwards compatible. There's all kinds of different things that you guys can do, which brings me to I'm a startup founder as well. So I understand the journey that you're on, or I think I do, but I would love to hear more about that specifically, like how you guys got started as founders. How's the fundraising process been? I have a hardware adjacent startup too. So, know the challenges of fundraising for hardware based businesses. Like, how's that been? What's happening? How's it going? Tell us about what's going on.
We got started in 2023, and then, I can say it's been extremely challenging. It's extremely hard to raise money as a first-time founder in the hardware space. We were lucky enough to get into Antler, which is like a
I love
VC
it.
firm. They do accelerators in the US and in Europe too. And we got into their Austin accelerator in 24. They gave us our first check that kind of helped us build the prototype and go out and get customers. And then in total, since then, we've raised a small friends and family round from the accelerator and from angels in our network. So that has kind of helped us build the prototype we have today, and then go and do these demonstrations. Where we are in the fundraising journey right now is we are going to very soon, in a week or so, announce our next raise, which is our pre-seed round, where we're trying to raise to build against these two pilots we have committed for next year. One with a commercial parking operator and one with an education institution. But that's
Amazing.
what we are doing right now in terms of fundraising. But yeah, I think it's very different in terms of the process than when you're raising a software only kind of company and you're raising for that. In hardware, you get a lot more questions about how long will it last. And then you think about, you only have very few pivots you can make with the funds you have, but in software, you can make unlimited pivots. So in that way, both of us being first-time founders, it's been like very real, very hard. But I think our motto is we've persevered throughout the process, and we've got interested customers who really want this product. And then now it's a matter of being able to raise against this interest and deploy this commercially ready solution.
What would you say just in that fundraising journey? What's been the biggest challenge? And I always ask this of startup founders: what's the most ridiculous question you've ever been asked?
Well,
Where to begin?
I'll start, Madhav. I'll take the most difficult part. I mean, I think people can tell you that like you're going to hear a lot of no's, right? Like a lot of people say, invest or fundraising is a numbers game, right? Go out there and just go hit the beat. But like, to go and get 60 or 80 or 100 no's, where someone, you've sat down with somebody, they've looked deeply at your business and they say no, that this is not a fundable venture for them. That's tough. I'll say, like, especially when you do it 20, 30, 50 times, right? It's like, again, you're like, man, these people, this is what they do for a living. And they just, they look deeply at your business and like, nah, not me. I'm not doing it. And you're like, everyone says you got to go and do that. You've got to slog through 100 no's to get one yes. And it's still, I don't think I had prepared myself personally for hearing that many no's, even though that's completely part of the journey.
Yeah,
It's funny you say that. I always tell people, and I tell other startup founders, I want to get to the no as quick as possible.
Yeah.
Like get me to the no. If there's like a twinge in the back of your mind that it's no, just say no.
Yeah.
It's fine.
Right.
And just I'll just tell you, because I'm sure you guys can relate to this. When I was fundraising for my last startup, one of the things I heard all the time was, "Oh, you're too early for us. You're too early for us." So I actually bought you'retooearlyforus.com and had a line of like t-shirts and hats that all just said, "You're too early for us." So then anytime someone would say that on a call, I'd be like, "Well, go to you'retooearlyforus.com and you can get a hat that says it. You don't even have to tell me you're too early for us." But okay, Madhav, what's yours? What's the craziest question you've been asked?
I think the most craziest questions is like, does it work? Because for us, we see it work every day, and then we kind of do a lot of demos. So when someone says like, how can it work and does it work? It feels crazy to us. But again, I think we just show them the video, and then that's the proof that it works. I think going back, the hardest part of the process is how long the sales cycle is. I think in the parking industry, I think in general fleets, the sales cycle is extremely long. It's unlike what we both experienced back in like our tech careers, quick decisions. But yeah, I think that's been frustrating because you start and then it's months down when you don't hear back, and then suddenly you hear back something, and then it's a bunch of people you have to go through. That's been very frustrating, but I guess that's part and course of the business we are in.
But you know
Of
what?
the journey.
You've identified a back door to get into the parking lots, which I think is brilliant. And that is, you can see who's already invested in EV charging. And now that they have those units, they've already decided, all right, I'm getting in here and I've made the plunge. Here's my ROI. And you can just go and say, all right, I see you're forward thinking. Let me show you how I can make you more money on these allotted spots and turn
And
2 spots into 10 or 20.
and that's the reality, right? Is these commercial parking operators recognize this is a thing that they're going to have to do. They didn't set out to be energy service providers, but now the public is expecting this now. And so the smart ones have made, sort of VP level folks head of EV charging, right? And so that they can specifically figure out, how do I do this service best? And what's really interesting is when you come together with, we have a customer, trying to figure out a situation with an airport, and airports are a very interesting scenario. It's a big industry. Airport parking is a huge industry. And what's interesting about it is you have dwell times of 3 to 5 or 10 days,
Yeah.
right? And if you
Yeah,
stick
yeah,
a
yeah.
level 2 charger into a car, and the person leaves for 5 days, the utilization of that asset is awful. It's like
Yeah.
3%, maybe less. And so what we've heard from airports themselves is, we're not deploying level 2 charging anymore. We're gonna think twice about this. We might do level 1 charging. The problem with level 1 charging is then you end up doing a lot more construction because you think you can cover a lot more spaces, and now you've just increased project costs to deliver a worse service, even though it is more applicable for the dwell times. And so airport EV charging is in a really tough spot because of dwell times and utilization rates. And our solution is really great in those scenarios. And we've really enjoyed the conversations with those parking providers. And we're excited there's something on the horizon there. And I hope we get to execute and announce that soon.
Wonderful. So on that note, we are running out of time here. Talk to us about just what's the roadmap looking like for the next 3 to 5 years, both with inductive robotics and I would say this style of charging in general.
Maybe I can start with in terms of like the commercial, like where we want to go. The goal of 2026 is to do 2 pilots, 2 or 3, but mostly 2 with very different kind of customers. So one with commercial parking setting, and one with the university setting where we've seen a lot of interest from education institutions. And then at the back half of 2026 is when we see ourselves developing a commercially ready solution we can go out and sell to parking operators. Maybe on the tech side, Dave, you can kind of take us through where we are going.
Yeah, on the tech side, it's very simple. It's, bring this demonstration project into a commercially viable product. That's so much easier said than done. And there's a ton, regulatory and engineering underneath that, and safety. It's very clear, to us that that's what's going to be required is, make it something that people can come see live and feel like they can have confidence buying into. And that's the goal for 26.
And then seeing beyond that, I think we see a future where we make a play in the autonomous car industry. So if you see all the Waymos and the Zooks out in the world, and right now they are at maybe level 4 or 5 autonomy, meaning the car is fully autonomous in the whole equation. The charging is still manual. I think we see a world where these autonomous cars are fully autonomously charged by our robots in their fleets. I think that's where we see ourselves far in the future, maybe operating in a fully automated futuristic parking lot where where an autonomous car comes in and a robot goes and charges the car. Maybe there are autonomous robots cleaning the cars and getting them ready for the next ride. But that's how we imagine the future, maybe in the next 10 years. It might be coming soon.
That's once again, very Wally.
I have a very important one. Is it very Wall-E, or when are you going to introduce an R2-D2 Star Wars themed shaped robot to do this? Because he even has the little arm that comes out of him, right? Come on, this is perfect.
What I'm super excited about is I think there's going to be a ton of opportunity to have some fun with this, right? Like,
absolutely.
And of course, you have to tread the line between Wall-E and Terminator, right? So like you can't you can't go off the deep end. But to your point, like I do think there's an opportunity, to work with all kinds of great partners to have some fun with bringing robotics into this public space, making it a joyful experience for people. That like, I'll just say, I guess like when we're doing testing, I'm testing in parking lots all the time. People love this. People come up, they're so curious. They want to know more. As soon as I tell them more, they're like, especially the EV owners are like, oh my gosh, how can I help? I want you guys to be successful. I want this. And it's been such a joy to talk to people about bringing robotics into parking, into EV charging. And I'm really excited to bring that to reality and show people that like, this is going to be such a good time and so much fun along the way.
I was just thinking, there's all these videos. I don't know if you guys have seen these of these autonomous security robots, that kind of roam around parking lots. And I always think about like, there's all people pushing them over and stuff like that. I just imagine people thinking like, man, how cool is this? Like, obviously no one says fuck the robot charger. This is going to be such a friendly addition to your neighborhood parking garage.
And that's, that's we're coming at this really trying to help people. And, instead of, security robots have their own sort of way of helping. I think, you have to be mindful of perception. And we've seen a lot of projects go off the rails when, perception and community engagement isn't properly addressed. And unfortunately, you get some instances like that. So yeah, that's a reality we have to figure out. I do think we're at this moment where, last mile delivery robots are out on our sidewalks delivering, food to dorms and whatnot. I think this moment is going to be looked back upon as a very dynamic moment where this is when robots entered our public spaces, right? And before, this era, robots were all inside warehouses and factories, and they weren't looked at by anyone not a technician or an engineer. And now I think this is the moment where we're having robots enter our public spaces. We're going to get very familiar with having robots. In a couple of years, I'm confident we're going to see robots going down the sidewalk. We're not going to look twice. It's just going to be another thing that's just happening. We're used to it around us.
Wonderful. Wonderful. So Madhav, David, I want to thank you both for joining us and sharing your insight on autonomous EV charging solutions. Where can the listeners at home find you or Inductive Robotics?
Yeah, I think two places. Go to inductiverobotics.com. You can read about us, submit a contact us form. You can find us on our LinkedIn Inductive Robotics, and then reach out to us, and we'd be happy to kind of reply. And I think we have two big asks. One is we are opening our fundraising very soon. So if you or anyone in your network knows investors who'd be interested in this opportunity, reach out to us. And the second ask is, we have a lot of interest from the commercial and the fleet sector. So if you know any partners who'd be interested in piloting this, reach out to us as well. But yeah.
All right. Well, thanks once again to Madhav and David from Inductive Robotics and for what you're doing to help push the boundaries of what's possible in EV charging. I really, truly can't wait to see your solution in a parking lot near me. Thanks for listening to the Urban EV Podcast. Don't forget to subscribe and share this episode with a friend or a colleague. The road to sustainability starts at the plug, and that's why we're here. We will see you all next week with a new episode of the Urban EV Podcast.